Okay, we are going to start with 1.3. On your notes I uploaded, I said 1.1 to 1.3. I apologize. That was 1.1 to 1.2. So we'll start with 1.3 here. Notice this section here you are going to use in the next few examples. So refer back to that. Also in week 1 weekly folder, you have something that's called Chapter 1 Formulas. Those formulas also will be helpful in this unit. So go ahead and you might want to print those off or have those up on your computer and look at those. So keeping with this stuff in mind right here, we're going to use these formulas when we start working on example 1. So if we go down to example 1 here, what it wants us to do is it says the terminal side of an angle theta in standard position passes through the point 815. Find the value of the 6 trigonomic functions of the angle theta. And the 6 trigonomic functions that they're talking about are again these right here. So you're going to have to keep those in mind as you're looking through the example. So if we scroll down, so let's look at, it tells us that points 815, so really our x equals 8 and our y equals 15. And so if we're going to find r, because we need r, because if you look back, scroll up here, some of those have the r in it. And then it tells us in order to find r is square root of x squared plus y squared. So if we go back down here now, and we start in our examples, we can say that r equals the square root of 8 squared plus 15 squared, which if we square that, we would have 64 plus 225, which would give us the square root of 289, which when we take the square root of that equals 17. So now we know that our x equals 8, our y equals 15, and our r equals 17. So we can go back to those 6 trigonomic functions and plug those values in. So we know that sine of theta equals y over r, and we know our y value is 15 and our r value is 17. So the sine of theta is 15 over 17. The next trigonomic function we're going to work on is the cosine of theta. And the cosine of theta is x over r, which we know our value of x is 8 and our value of r is 17. So now we know the cosine of theta is 8 over 17. We go to our next one. Our next one is tangent of theta. And tangent of theta equals y over x. We know our y value is 15 and our x value is 8. So we know that tangent of theta is 15 over 8. So then we go to our next function, and it's cosecant of theta. And we know that cosecant of theta is r over y. Our r value is 17, and our y value is 15. So cosecant of theta is 17 over 15. The next one we're going to look at is secant of theta, and secant of theta is r over x. We know our r value is 17, and our x value is 8. So secant of theta is 17 over 8. And our last trigonomic function is the cotangent of theta. The cotangent of theta is x over y. We know our x value is 8, and we know our y value is 15. So in cotangent of theta is 8 over 15. Moving on to our next portion, it tells us we need to find the terminal side of an angle in standard position that passes through -3, -4. It wants us to find the value of the 6 trigonomic functions of angle theta. So we're going to do the same thing as we did previously. So we know that our x value is our -3. Your y value is -4, and we have to find our r value again. And so to find our r value, we are going to take the square root of -3 squared plus -4 squared, which is going to give us the square root of 9 plus 16, which gives us the square root of 25, which gives us 5. So we look back and our x value is negative 3, our y value is negative 4, and our r value then is 5. So we go to find sine. We know sine of theta is, we put our theta in there, sine of theta equals y over r. And so our y value is negative 4, and our r value is 5. So sine of theta equals negative 4/5. Cosine of theta then equals x over r, which equals our x value is negative 3, and our r value is 5, so that cosine of theta is negative 3/5. Then we're going to put in our tangent values. Our tangent of theta is y over x, which equals our y value is a negative 4, my x value is a negative 3. Two negatives cancel, a negative divided by negative gives us a positive, so tangent of theta is 4/3 positive. Then we go down to our cosecant of theta. Cosecant of theta is r over y. Our r value is 5, and our y value is a negative 4. So you could write that like that, or you could write it a negative 5/4, same thing. Then we go to our secant of theta. Our secant of theta is r over x. We know our r value is 5, and our x value is negative 3. So secant of theta is negative 5/3. Our last function is cotangent of theta. Cotangent of theta is x over y. We know our x value is negative 3. Our y value is negative 4. Negative divided by negative is positive. So our cotangent of theta value is actually a positive 3/4. Okay, if we scroll down to our next example, it says find the 6 trigonometric functions of the angle theta in standard position if the terminal side of theta is defined by x plus 2y equals 0, or x has to be greater than or is equal to 0. So if that's the case, then we can use any point except 0, 0. So if we go to solve this equation here, I'm going to just say that x can equal 2. So I'm going to say let x equal 2. So then what I can do is I can plug in this 2 for my x value here. So I can say that 2 plus 2y equals 0. Subtract 2 from both sides. So I have 2y equals negative 2. Divide both sides by 2, so y would equal a negative 1. So now I have the value that x equals 2, y equals negative 1, and I have to find my r. So now, that's a little messy, sorry about that. So now to find my r value, I'm going to plug my x and my y in, and I'm going to say r equals the square root of 2 squared plus negative 1 squared, which is going to give me the square root of 4 plus 1, which gives me the square root of 5. So r is going to equal the square root of 5. So now I have my x, my y, and my r values. So again, to find the 6 trigonometric functions, we just plug those values in. So sine of theta equals y over r, which equal y is a negative 1 over r, which is square root of 5. We cannot leave a square root in the denominator, so we just multiply both the numerator and the denominator by a square root of 5 to rationalize the denominator. So that would leave me with equals the square root of 5 negative divided by, over 5. So sine of theta then would equal negative square root of 5 over 5. And then we go down to, let's do cosine. So I'll do that one right here. Cosine of theta equals x over r. So we know our x value is 2, and our r value, again, is a square root of 5. So again, we need to rationalize the denominator. So I'm going to take that times the square root of 5, or square root of 5, which gives me here 2 to the square root of 5 over 5 as our answer. So cosine of theta equals 2 to square root of 5 over 5. Then I'm going to find the value tangent of theta. which equals y over x. My y value is -1 and my x value is 2. So my tangent of theta is -1/2. Cosecant of theta equals r over y. My r value is the square root of 5. My y value is a -1. We don't need the -1 in the denominator, so I can just write that as square root of -5. So cosecant of theta is negative square root of 5. Secant of theta is r over x. My r value is square root of 5. My x value is 2. So secant of theta equals the square root of 5 divided by 2. Cotangent of theta equals x over y. My x value is 2. My y value is -1. I can get rid of my -1 in the denominator. So cotangent of theta equals -2. I apologize if this is going a little bit fast, but because it's a video, you guys can go back and stop and replay it. So hopefully this makes sense. Really, it's just plugging in your x, y, and your r values. Okay, moving on to our next example. Go to the next. Excuse me. It says, find the value of 6 trigonometric functions for each angle. So if I have an angle of 90 degrees, again, what I have to think about is, I'm going to draw it over here for you. If I had my point for your 90 degrees is going to be right here, right? This angle here. So what I can do is I can pick any point on my axis right here, and or if this be 90 degrees, we know really a 90-degree angle looks like this. So what I'm going to do is I'm going to say that this is my x value here, which is 0, and I'm going to say my y value here is 1. So I'm going to say that x equals 0, y equals 1, and if we, again, find our r, which is square root of 0 plus a square root of 1, that's really just going to give us 1. So then I know my r value is going to be 1. Okay, so if I had square root of 0 squared plus 1 squared equals square root of 1, which equals 1. So that's my r value. So again, if I come down here, so I'm going to say the sine instead of theta, now we have 90 degrees. So sine of 90 degrees is y over r, which is 1 over 1. So my sine of 90 equals 1. Cosine of 90 degrees is x over r. My x value is 0. My r value is 1. So then cosine of 90 degrees equals 0. Then we go to tangent of 90 degrees. Tangent of 90 degrees equals y over x. Well, my y value is 1 and my x value is 0. You cannot have 0 as a denominator, so tangent of 90 degrees is undefined. Okay, then I'm going to go for my cosecant of 90 degrees. Cosecant is r over y, which gives me a value of 1 over 1, which is just 1. So my cosecant of 90 degrees is 1. Then we go down to secant of 90 degrees. Secant is r over x, which is 1 over 0. So again, cannot have 0 as a denominator. So again, secant of 90 degrees, is undefined. So we go to our last one, which is cotangent of 90 degrees. Cotangent is x over y, which is 0 over 1. So my cotangent of 90 degrees is 0. Okay, moving down to our next example here. It says an angle theta in standard position with a terminal size through -3, 0. So I know that my x is -3. Here, I'm going to draw the line here so we don't get messed up. I'll use a little green line. There you go. Sorry, it took a second. Okay, so my x value is a -3. My y value is 0, and I have to find my r value. So my r value, if I have -3 squared plus 0 squared which gives a square of 9, which gives me 3. So my R value then is, is 3. Okay, so just finding my values again, I have sine of theta, which is going to be 0 over 3, which is 0. If you don't remember what the values as far as x, y, and r are, go ahead and refer back to your chart on your formulas, or you can look at the beginning of 1-3. I'm just going to give you the answers for this one. Okay, testing you a little bit. So when I have cosine of theta, it's going to be negative 3 over 3, which is going to give me a negative 1. Tangent of theta is going to be 0 over negative 3, so tangent of theta equals 0. Cosecant of theta is 3 over 0. We know again we cannot have 0 as a denominator, so that one is undefined. Then we go down to secant. Secant of theta equals 3 over negative 1, which will give us a negative 3. So secant of theta equals negative 3. And cotangent of theta equals negative 3 over 0, which we know we can't have 0 as a denominator. So that one is undefined. Oops, I have to go back to my cotangent, or secant, I'm sorry. Look at your secant. Your secant is actually, secant is r over x. So I apologize, your r is 3 and your x is a negative 3, so this actually should be negative 3, which then would in turn give us negative 1 here. I apologize for that one. Okay, sorry about that error. If we go down to our next page, then that one's just really filling the blanks here. So you can even plug these into your calculators to find these values, but sine of 0 is 0, cosine of 0 is 1, tangent of 0 is 0, cotangent of 0 is undefined, secant of 0 is 1, and cosecant of 0 is undefined. So if we go back down to our 90 degrees here, sine of 90 degrees is 1, cosine of 90 degrees is 0, tangent of 90 degrees is undefined, cotangent of 90 degrees is 0, secant is undefined, and cosecant would give you a value of 1. If we go down to 180 degrees, sine is at 0, cosine is negative 1, tangent is 0, your cotangent is undefined, secant is negative 1, and cosecant is undefined. Sine of 270 degrees is negative 1, cosine is 0, tangent is undefined, cotangent is 0, secant is undefined, and cosecant is a negative 1. If we go down to 360 degrees, sine of 360 is 0, cosine is 1, tangent is 0, cotangent is undefined, secant is 1, and then cosecant is undefined. So if we go down to our reflect here, it says which row in the table, I'll leave that in case I finish it, which row in the table gives the trigonometric function values for an angle measuring negative 270 degrees. Measure 1,350 degrees. So remember, you can't have a negative, and so if we go around, that would end up being 180 degrees. That's it for section 1.3. If you need to go back and review, you can. If you have questions, I can go over this next week in class again also.